Hello students, let's continue moving on. This is actually a chapter on graphing. So let's look at graphing quadratic equations. So our axis of symmetry, that's the reflection line that our parabola matches on. Remember our formula is x equals negative b, or the opposite of b, over 2a. That's the formula we use to find our axis of symmetry. And our vertex, because our vertex is a coordinate, it ends up being x, y when you consider our equations that we're rolling with were ax squared plus bx plus c. And so that vertex is going to be a coordinate, either a maximum or a minimum, depending on which way our parabola is facing. Once you've identified your axis of symmetry using this equation here, you can take that answer and substitute it in for x to your equation, plug it in, and then you'll end up finding out what y is in this particular case. And once you have that, you then know your coordinate of your vertex. We're going to go ahead and try that out on this one. So we're going to graph, label the axis of symmetry, the vertex, and the roots, which is also called the solutions of the equation. All right, let's see what we got here. Here's our equation. Now I can see that my a term is positive, so that tells me that this is going to point upward. This is an upward one. I'm going to go ahead and find my axis of symmetry. So it's the opposite of my b term, which I know what it is. It's 6. So the opposite of 6 over 2 times my a term. So that's negative 6 over 2, which is negative 3. So I can tell that my axis of symmetry is going to be at negative 3. So x equals a negative 3. And I want to label that on my graph. Make sure you all do that. So my parabola is going to work around that. Okay, now once I know that, I can find my vertex by substituting in wherever x is. I can put in my negative 3. So my equation is negative 3 squared plus 6 times negative 3 plus 9. I end up with 9 minus 18 plus 9, and that gets me to 0. So I know that my vertex is going to be at negative 3, 0, right there. Negative 3, 0 is my vertex. Now to get the rest of the graph, I need to go ahead and work out a t-chart on some different pieces here. I know negative 3, 0 is one of them. I also pre-worked out a few problems, so negative 2 ends up at 1. So negative 2, 1, got a point there. And negative 1, 4. Negative 4, 1, 2, 3. 1, 2, 3, 4 right there. And because of the axis of symmetry, I know it reflects off of the other side. And I can see that my parabola goes like this, pointing upward. And there is my parabola. All right, I'm going to press pause on this one, and I'd like you to go ahead and try this one out. Go ahead and get your axis of symmetry. Go ahead and find your solution by graphing this out. I'll let you know right now that you're going to have to change your interval of your y-axis because it ends up being so big. So I'll tell you right now, so my x's I went by 1s, and my y's I went by 5s to graph this out. So go ahead, press pause, and you give it a try. Okay, so far I found my axis of symmetry being at negative 4. Now I'm going to go ahead and find my vertex by substituting in negative 4 for each of the x's. I'm going to press pause though. All right, when I substituted that in, I ended up getting negative 2. So my vertex is at, not negative 2, negative 25. That's what's so big about it. So it's at negative 4 and 25. So 5, 10, 15, 20, 25. So it's going to be right here at the point of negative 4 and negative 25. Now when I plot some points on this to go ahead and get my parabola running, I noticed that negative 4 and negative 25 works. I had negative 3 and it was like negative 24, so that was going real slow. So I tried a few other things. I tried 0, negative 9, I tried negative 2 and I got negative 21. So let me plot a couple of those out. So -3, -24. I mean, that's like right there. So that's not a whole lot of change. 0, -9, so 5, 10. So it's like right there, throwing me off a little bit. And 1, 2, 3, 4, 1, 2, 3, 4. So it's like right here. And I need to keep going because I also need to find the solution where I crossed the x-intercept and I tried 1 and it went out to 0. So 1, 0 also worked. And if that works, then according to my line of symmetry, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, that is also a solution. So now I can graph my parabola right there, and my solutions are right here, being at 1 and -9. All right, we're going to do some solving by factoring. Remember, the first thing you want to do is you want to set everything to 0. Okay, set all of it to 0 before you get started. And that way we can factor a solution out in case we don't have graph paper or we want to try something different here. So let's graph this out. Okay, first thing I want to do is I want to check to see if there's a GCF, which there is not. The second thing I want to do is see if my A term is 1, and it is. So first thing I'll do is I'm going to go ahead and I'm going to see, okay, what times what gets me -24, that when I add them together I get 2. And I tried a few things and I found that 6 and -4 work. So that tells me I need to work with x plus 6 and x minus 4, and I need to zero out each of those. So I end up with x equals -6 and x equals 4, those being both of the solutions. Okay, why don't you try this next one? Why don't you press pause and try number 11 for a moment. Remember, check your GCF first. All right, how'd you do? I factored out a 5x, so I end up with 5x equals 0 and 3x minus 4 equals 0. And that left me with x equaling 0 and x equaling 4/3. Those being my two solutions, or my two roots to my parabola. Factor completely and then solve. Okay. Let me do the first one with you, and then we can work on some of those. So I can factor out something on this. On 12, I can factor out a 25. And I end up with x squared minus 4 equals 0. 25 and that x squared, that is the difference of a perfect square. So difference of squares are going to put me here, not 4, that's 2. The difference of squares looks like that. And then that means that I need to zero everything out. And so I can see that that's not going to work. 25 equals 0, not true. X equals a -2 and x equals 2. So those will be my two solutions on that one. Number 13 and 14, why don't you go ahead and press pause and work out those. Make sure you're careful on those. Zero both of those out before you solve them. Press pause, give it a try. All right, this is where I ended up. I ended up with 3x squared plus 3x minus 5x minus 5. I'm going to do some grouping here. And I can factor out of there, so I end up factoring out 3x, and I get x plus 1. And I can factor out over here a 5, and I get an x plus 1. And I can see that I end up with 3x minus 5 and x plus 1. And if I simplify those out, or zero those out, I can see that my answers are going to be x equals 0 and x equals, I had 5 to both sides, I divide by 3, I end up with 5/3. So my two solutions for that is going to be x equals 5/3 and x equals not 0. That is so not true. Not true, not true. That's so much more truer-ness, nader. All right, number 14, you're going to work out the same way. All right, I found out that -5 and -5 gets me to 25 and the -10. I split that up, so I saw that my -10x is made up of -5x and -5x. I regrouped them, factored those out, so I'm ending up with x minus 5 times x minus 5. So it's going to be the same answer, which gives me x equals 5. And that gives me one solution on these guys. Oh, factor completely. Oh yeah, we can do these. Oh, this looks interesting. So on number 16 here, okay, they're locked. That's okay. We can work with these. So on number 16, I can see it's already zeroed out. I see some nice perfect squares worked out here. So I can see that this equals 9x squared minus 7 squared equals 0. And that tells me that I'm looking at 9x minus 7 and 9x plus 7 because they are the difference of squares. And when I simplify these out, or equal both of those to 0, I end up adding 7 to both sides, dividing by 9. So x equals 7/9. And this side is subtract by 7, and then I divide by 9. I end up with negative 7/9. Number 17, you know, I kind of took me a little while to work through this guy. You know, I factored out of this one a 4. So I factored out a 4. I ended up with 4x squared plus 15x minus 25. And with this guy, I ended up trying to find a perfect square that worked out because I saw 4 and I saw a negative 25, but I couldn't get to my 15. So it was actually kind of deceiving. So I went back over here and tried my x thing. So 4 times negative 25 got me to negative 100. And then I needed to get them to add up to 15. And I found that 20 and negative 5 worked. So I was able to work with that. So 4x squared plus 20x minus 5x minus 25. And I did some grouping on that one. All right. Oh, I think there we go. I did my little x thing because I thought for sure I was going to get something out of the 16 and 100, but then I factored a 4 out. And then I was excited to see the 4 and the negative 25 because I thought maybe we could work with perfect squares on this one, but I couldn't get anything to get me to this 15. So I broke it into 20 and the negative 5 and kept working it out, grouping it, and pulled out that my answer, 4 does not equal 0, can't use that. X equals 5/4 and x equals negative 5. How exciting. Factor completely and then solve. Okay, for these 3 right here, I'm going to go ahead and press pause. You work through them, and then let's check back together and see how we did. Pause. Pause, pause, pause. All right, let's take a look at how you did on these ones. For number 18, I ended up getting, okay, so I ended up at, I factored out a 2 once I got the 19 over to this side and saw that negative 16, and I ended up with x squared minus 8. Now that'd be really nice if it was like minus 4, because then I'd have a difference of squares, and it would be x plus 2, x minus 2, but it isn't, it's minus 8. So I ended up running down the road of radicals. So I found that x squared equals 8, so x equaled plus or minus the square root of 8. I factored out the 4, which became the 2, and there I am. So my answer is 2 times the square root of 2 and negative 2 times the square root of 2, and 2 equals 0, that drops out. Number 19, this is a really simple one, and some of you, you'll overcomplicate this, you'll overthink this, so be careful on that one. Just remember, the first thing is the GCF. So take a look at this guy. Factor out the x, and you end up with x equaling 0, which is one of the solutions, and x equals negative 8. So do not overthink those ones. Try not to. I'm missing a C term on this one. Work that out. Number 20, I tried something with radicals. I ran like down a few different roads, and then I went and looked at the test. That's not on the test. So we'll not do number 20. I had some fun trying it though. I had a blast, and I got to an answer that ended up being quite a radical. It was radical, and then I thought to myself, why am I asking you to do that? Let's talk about the quadratic formula. Oh yeah! It's about time we talk about this thing. In fact, we don't just talk about it, we do some singing, don't we? Oh yeah. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So when you are factoring, ultimately you want to try the factoring or using a graphing calculator or use the quadratic formula if it doesn't seem like you can find any of them that are working out. So let's practice that out here. Okay, in this equation, x squared minus 7x plus 12 equals 0. So when we get to 0 that out, my a term is 1, my b term is negative 7, and my c term is 12. So I can write it out. Negative of negative 7 plus or minus the square root of negative 7, and I'm squaring the whole thing, minus 4a, which is 1, c, which is 12, all over 2a. And I just start working through simplifying this, and I end up with 7 plus or minus the square root of 49 minus 48. Oh, that's going to be nice. All over 2. And I end up with 7 plus or minus the square root of 1 over 2. And square root of 1 is 1, so it's 7 plus or minus 1 over 2. And this is where I run down my two roads here. So I'm checking with 7 plus 1 over 2 and 7 minus 1 over 2. 7 plus 1 over 2 is 8 over 2, which equals 4. And then 7 minus 1 is 6 over 2, which equals 3. So those are my two solutions using the quadratic formula. All right, why don't you try it? Solve these equations using the quadratic formula. Leave it as a radical. Ooh, hint. What's the hint? What's the hint? Rewrite the second equation in standard form. Rewrite the second equation. Oh, gotta keep that in mind. Keep that in mind. Rewrite the second equation in standard form. Pause. All right, for this one, using my quadratic formula, I kept working through simplifying, and I get down to here what's in black, negative 4 plus or minus 6 times the square root of 2 over 4. And I'm going to do some simplifying here. Now notice that all these terms here can be simplified. I can't simplify the radical, but I can simplify the 6. Now keep in mind, I can't just simplify the 4, like I can't go 4 over 4 equals 1, but I can take all the pieces of it. So I'm going to do that. So everything can be cut in half. So I can do negative 2 plus or minus 3 times the square root of 2 over 2. And that is what this looks like simplified. Now keep that in mind. You can also multiply what's right in front of the radical, or you can only simplify what's in front of the radical, and you must simplify all the terms. All right, number 4. Let's go ahead and try this one. Press pause, give it a try, and see what happens, and leave it as a radical. Okay, this one I was really trying to leave it as a radical, but I ended up with negative 5 plus or minus the square root of 1. Square root of 1 is 1. So I just kept simplifying down. I ended up with 2/3 and 1 as my answers. All right, sometimes we run into a situation where we utilize the discriminant. And the discriminant, remember, is that piece that sits in the square root. Okay, that's it's kind of in the square root of our quadratic formula. So it's b squared minus 4ac, not including the square root. And if you end up solving this in, if you end up plugging your b term, your a term, and your c term, and if your result is positive, then that means you will have two solutions. If your answer is negative, when you do the whole thing, that means there are no solutions. Now keep in mind, that doesn't mean 0. That means actually no solutions, and you'd write that down, no solutions. If you simplify that out to the discriminant and you end up with 0, that would mean there is one solution. One solution. So let's go ahead and try that out. Okay, we're going to work through each one of these ones. I'll do the first one with you, and I'd like you to try the other ones. So if we continue to use right here the inside of the square root of our quadratic formula, the discriminant, I can go and see that it's negative 1 squared minus 4ac. And I simplify that out and I get 1 minus 8 and end up with negative 7. And this tells me that there are no solutions. Why don't you press pause and you work these ones out. All right, for number 31, there's 2 solutions. For number 32, there is 1 solution. And that's something that some students might mix up a little bit, seeing the 0 and wondering if that means 0 solutions. No, no, 0 means there's 1 solution, that this thinks that this parabola sits somewhere on the x-axis. And we're just trying to find out where. Where does it sit? And the 1 solution, that vertex is sitting there somewhere. No solutions for my graph. That means that my graph is sitting above it somewhere, so it's not hitting the x-axis at all. And for 2 solutions, it is sitting somewhere below it, or it might even be inverted and go this way. So it could possibly be that way as well, and thus not crossing the x-axis, and thus having no solution, or 2 solutions for 31. And actually 30, it could go like this too. It could invert and go the other direction as well. All right, well, thanks for practicing these concepts with me. I'm going to go make a tuxedo out of gummy bears and walk through a preschool playground just to see what happens.